In this video, I want to demonstrate how to use the Analytic Solver to transform categorical variables to dummy variables. This is a very small data set that I only have 7 records, and I have 2 categorical variables. One is gender, the other one is education. For gender, I only have 2 unique values, female and male. And for education, I have 3 unique values, high school, college, and grad school. Now, for machine learning algorithms, it can only take numerical values. That's why we need to convert categorical values that look like text-based categories into dummy variables that has dummy values, which is ones and zeros. So we want to basically convert you. If you want to convert manually, that will be you will code female to 1, then male into 0, female 1, 1, 0, 0, 0 again. And this one you will have 0, 1, 0, 2, and then 1, etc. Now, if you have a lot of data, it will be tedious, right? So we could use data analytic solver or similar software to simplify the process to automate this. So under data science, under transform, select categorical data, create dummies. And it will have a pop-up window. So if you don't see the variables here, you can uncheck and check again the first row contains headers, it will show. And now if you have many variables, you can just select the ones that you want to convert, select those categorical ones. And you can use the shift key or control key to select multiple variables and to process at the same time. And that's it, just click OK and wait. So depends on how your data set size. It may take a while, but once it's finished, you will see a new worksheet created called encoding in here. And when you click it, you will see that 7 records is the original, how many records I have, however many records originally you have, it will show in here. And then we now see from 2 variables, we now have 5 variables. So we have 2 for gender, gender female and gender male. And we have 3 for education, education college, education grad school, education high school. So for the first record, we can tell that it is a female and it has a high school education. So going back to our original data, and it matched with the first record, female and high school. And so one thing I want to note here is that we try to avoid multicollinearity before processing, like when processing the machine learning model, because multicollinearity basically means 2 or more variables are, the independent variables are highly correlated to each other. Now that could bring bias to our models, so we want to avoid that. So for example, in here, if I am I have a record 1 to be female, for sure, the gender male would be 0. And vice versa, record 2 is 0 for the female, then for sure it has a 1 for the male. So because I have only 2 unique values, female or male, I only need to keep 1 of them. So I can keep the gender female in the data set to further process with machine learning modeling, or I can keep the male and remove the female, or not choose the female. So similarly with education, so if you have a college, grad school, and high school, and each record in your data set is either high school or so they're all exclusive, then you only need to keep 2 of them. So the total number of the unique values minus 1, that's the number of the newly created dummy variables you want to keep. So you can pick any of this. You want to remove the high school one, then you only have education, college, and grad school. So now even if you remove this column, you can still tell the education, right? Record 1, if you only keep college 0, grad school 0, then for sure your high school will be 1. Now that is to assume that you don't have any missing data. If you have missing data, you could keep all 3, and you should keep all 3 columns. Also note that some machine learning models will not accept missing data, such as linear regression, because you need to calculate distance, and so you cannot find a number to calculate what bump into an error. So that's it. Hope this is helpful.